Good day everyone. In today's class, I'm going to provide solutions to these Cambridge topical questions on trigonometric equations and trigonometric identity. So the first question we're going to consider here is given as alpha equals cos inverse of 8 over 17. Then we should find the exact value of this 1 over sine alpha plus 1 over tan alpha. Mind you are told not to use calculator for you to get the exact value. So first thing you have to do here is that, okay, since you have it here that alpha is cos inverse of 8 over 17, okay, so which implies that 8 over 17 equals cos alpha. And mind you, we have it from Sukatua that cos alpha or cos theta is given to be adjacent over what? Hypotenuse. So which implies that the adjacent here is going to be 8 and hypotenuse here is going to be what? 17. Okay, and for us to have adjacent and hypotenuse, we can only derive that from a right angle triangle. So let's say we have a triangle of this form, okay, so such that this place here is 17 and let's call this to be 8, where this is going to be the angle alpha. Alright, so the next thing to find is the opposite. So where we can make use of Pythagoras theorem, which is hypotenuse squared equals opposite squared plus adjacent squared. Okay, so opposite now is going to be square root of the hypotenuse, which is 17 squared, minus adjacent, which is 8 squared. Alright, and from there, when you take that, you have opposite to be 15. Okay, so now we have opposite to be 15, adjacent has been given to be 8, and then hypotenuse is given to be 17. Okay, so to find 1 over sine alpha, remember sine is given to be from Sukatua, that's opposite over hypotenuse, right? Then tan is given to be what? That's adjacent over what? Opposite over adjacent, opposite over adjacent. So let's make substitution of what we obtain in sine alpha, which is going to be 15 over 17, while tan alpha is going to be what? 15 over 8. Okay, so these two results now, we have sine alpha to be this, tan alpha to be this. Make the substitution here, then we are going to have 1 over sine alpha plus 1 over tan alpha. That's going to be reciprocal of this to be 17 over 15. Likewise, reciprocal of tan alpha, that's going to be 8 over 15. Then this is going to be what? 5 over 3. And that is the solution to the given question. Okay, so let's consider the next question, which is given as express the equation 3 cos theta equals 8 tan theta as a quadratic equation in sine theta. So of course you know a quadratic equation to be of this form: ax squared plus bx plus c. This is a quadratic equation where the unknown variable is x. But what we have here, we have to express this as a quadratic equation in terms of sine theta. So which implies that we are expected to write everything here in terms of sine theta. Okay, so we have 3 cos theta, then 8 tan theta. So you should remember that tan theta can be written as what? Sine theta over cos theta. Alright, so make the substitution there. You have 3 cos theta equals 8 multiplied by what? Sine theta over what? Cos theta. Okay, so you multiply both sides by cos theta. Now this becomes 3 cos square theta equals 8 sine theta. So one of the properties of one of the identities of trig, we have it that sine square theta plus cos square theta is going to be 1. Okay, and since you are trying to express this equation in terms of sign now. So we need to eliminate cos squared, and the best way to go about that is to make cos squared theta as the subject of formula A. So by implication, cos squared theta becomes 1 minus sine squared theta. So we can now make substitution for that here. That's going to be 3 in brackets 1 minus sine squared theta, okay, then minus 8 sine theta, equals 8 sine theta. So expand the bracket, this is 3, then minus 3 sine squared theta equals 8 sine theta. So then we finally obtain 3 sine squared theta plus 8 sine theta, then minus 3. So this is a quadratic equation in terms of what? Sine theta now. Alright, so that is that. How many marks? So that's 3 marks. So it's as simple as that. Then the sub question there is to find, you say hence find the acute angle in degrees for which 3 cos theta equals 8 sin theta. So one beautiful thing about, one of the things you need to understand about trig is that when you have something like this, you don't need to start solving this again, because this equation here is same thing as this. All right, so all we just have to do is to start from this here that we obtained here, then you continue the solution from there. So that is 3 sine squared theta plus 8 sine theta minus 3 equals 0. Okay, so to factorize this now, or to solve this, so let's y equals sine theta, so which means 3y squared plus 8y minus 3 equals 0. So product of minus 9 and sum of 8, so this can be written as 3y minus 1 and y plus 3. Okay, so which means that 3y minus 1 equals 0, y plus 3 equals 0. So we obtained it because for product of two factors to be 0, one of the factors must be 0. All right, so then from here you have y to be 1 over 3 and y equals minus 3. Now, so recall that y is equals sine theta, so you make the substitution for sine theta here to be 1 over 3, then sine theta here to be minus 3. So if you look at the second value of sine theta here, which is minus 3, there is no solutions here, so this has no solutions. Why no solution? Why do we have no solution? Why there is no solution in this place? Because anytime you have sine, the range of sine theta is between minus 1 and 1. Okay, so range of sine theta is minus 1 less than or equals to sine theta less than or equals to 1. So you can't have value of sine theta to be more than greater than 1 and less than minus 1. It is not possible. So it has to be between it must be between minus 1 and plus 1. Okay, so now, so let's consider the second one where we have sine theta equals 1 over 3. Yes, 1 over 3 lies within the range of sine theta, which is minus 1 to 1. Okay, so theta now is, you take sine inverse of 1 over 3. So sine inverse of 1 over 3 equals what? 19.5. So mind you, there are other angles we can obtain here that will give us 1 over 3. But you should note that we are strictly asked to find acute angle. Okay, so the only acute angle we can obtain for this is 19.5 degrees. So that is that. So moving on to the next question. So we asked to solve this. Tan theta plus 2 sin theta, then tan theta minus 2 sin theta equals 3 for the domain to be from 0 to 180 degrees. So what we're going to do here is just to express this equation in terms of one of the trigonometric ratio or 2 at maximum. Okay, so first thing to do is to cross multiply. So to cross multiply, we multiplied both sides by tan theta minus 2 sin theta. So the equation becomes tan theta plus 2 sin theta equals 3 in bracket of tan theta minus 2 sin theta. Alright, so you expand the bracket, this is going to be tan theta plus 2 sin theta. If you expand the bracket of the right hand side, that's going to be 3 tan theta minus 6 tan theta sin theta. So let's separate sine from cos. Okay, so this is going to be 2 tan theta, okay, then minus 6 sin theta equals 0. Okay, and again recall that tan theta can be written as what? Sin theta over cos theta. So by the time you change that, this is going to be 2 sin theta then over cos theta minus 6 sin theta equals 0. So to clear the denominator now, we have to multiply both sides by cos theta, and this is going to be 2 sin theta minus 6 sin theta cos theta equals 0. So the equation has been reduced to two terms, and when you look at the two terms carefully, there are factors of 2 and sin theta there, so that can be factorized. So by the time you factorize that, we left it 1 minus 3 cos theta equals 0. Is that clear? Oh, sorry, my bad. From this side here, if you bring 2 sin theta to this place, that should be minus 8. Sorry, so let's quickly change that. Minus 8 sin theta. So this is minus 8. So you factorize, now you have 4 outside here. Okay, so for product of this to be 0, one of that has to be 0. So it means 2 sin theta equals 0, or 1 minus 4 cos theta equals 0. So sin theta equals 0, or cos theta equals 1 over 4. Now, so what's the angle here? Theta equals sine inverse of 0, and that will give us what? 0 degrees. Okay, so then you take this cos inverse of 1 over 4, that should give us 75.5 degrees. Okay, so the angles are not restricted to these angles 0 and 75 degrees, but 75.5. But you should know that whatever you are going to get must lie between 0 and 180 degrees. Okay, so the remaining angles are outside 180 degrees, so that is why we have to stop here. So the angle here is 0 degrees and 75.5 degrees. Is that okay now? Okay, so moving on to the next question. Okay, so the question is given us: solve the equation 3 tan square theta plus 1 equals 2 over tan square theta. Okay, so what we're gonna do here is to cross multiply so that you can eliminate the fraction, the denominator, and that's gonna be 3 tan squared theta plus 1, okay, in brackets tan square theta. Alright, equals to, so you expand the brackets, and this should give us 3 tan raised to the power of 4 theta plus tan squared theta equals 2. Okay, so this form a quadratic equation, but we can reduce this to be a quadratic. Okay, so let's P equals tan squared theta. Okay, if you represent P to be tan squared theta, or if you represent tan squared theta to be P, then the equation reduces to 3p squared plus p then minus 2 equals 0. So this is a quadratic equation now, which I'm sure that this can be factorized. Product of minus 6 sum of 1. So this can be written as 3p minus 2 and p plus 1 equals 0. So which means 3p minus 2 equals 0, or p plus 1 equals 0. Then we obtain p to be what? 2 over 5. Then p equals minus 1 over 5. Alright, so where we have tan, remember p, we represent tan square theta to be p, so which means tan square theta equals 2 over 5. Then tan square theta equals -1. So yes, you have to be very careful here. For the range of tan is between -infinity to infinity. There is no limit to that. But for the case of sine and cos, that one is limited to -1 less than or equals to the range less than or equals to the function, then less than or equals to 1. So this is the range of sine and cos. Exactly. But when you look at this is tan squared, theta equals -1. There is no solution here. No solutions. Why? Can you answer that? No solutions here because square of negative, there is no square of any number, okay, must be what? Greater than or equals to 0. Exactly. Now, so you cannot get negative when you squared something. So it can only happen when you are taking square of imaginary or complex number. Alright, so tan squared must be greater than or equals to 0, and for us to have -1 here, it means that there is no solution there. Okay, so now moving on to the first one now, which is tan squared theta equals to over 5. So we take square root of both sides, and that's going to be plus or minus 2 over 5, which can be written as tan theta equals root 2 over 5, or tan theta equals minus square root of 2 divided by 5. Is that taken out? So let's find the angle for each of these. Then tan inverse of square root of 2 over 5, that will give us 39.2 degrees. And for the case of this, you have negative 39.2 degrees. So now, since, however, we can't leave your answer in as negative form, because what you have here, the angle you must obtain lies between 0 and 180 degrees. So we don't need negative results. So what are we going to do to get positive results for this now? We're going to add 180 to this, okay? Or you subtract this value from 180. So this is theta equals 180 degrees minus 39.2 degrees. So theta equals 180 minus 39.2 degrees. That should give us maybe 140.8 degrees. So the angles here are 39.2 degrees, then 140.8 degrees, and that is the solution to the given question. All right, so we're gonna stop here for today. So next class we're gonna continue from here. So don't forget to like, comment, and subscribe. Thank you.